Hello, everybody. Thank you for joining us at ISS 2020. We're ASMGI, and this is our hands-on DevSecOps tools workshop, part 3 of our DevSecOps series for this event. And today we have Alex Frankel from ASMGI and Tim Thompson from ASMGI. So take it away, Alex.
All right, good afternoon or good morning, depending on when you're turning in. We would like to welcome you to this presentation of the hands-on workshop with DevSecOps tools. I'm Alex Frankel. I'm a software developer at ASMGI, and I have my colleague here with me, Tim Thompson.
Yeah, I'm Tim Thompson. I'm a Senior Security Specialist here at ASMGI.
And today for our agenda, we're going to cover a few different tools that we use on a daily basis, and some are a little newer, some are good old standbys. They're static application security testing, or SAST, software composition analysis, or SCA, and dynamic application security testing, which is DAST. We're going to go through what these tools each are, why you may choose to use them, how to go about using each of these tools, and then we're going to take a look at a little bit of the output and try and interpret the results, followed by a little bit of action items and remediation steps that we choose to take. And then we're going to give you a few keys for success so that if you do choose to implement these, you will have a way to move forward. Static application security testing, or SAST, is what we're going to cover first here. So SAST is basically the scanning of your source code before it is compiled. It is extremely important to understand this is pre-compiled software. Doesn't have to be fully functioning. It's something that you're able to scan while you're in the process of developing. As compared to some other forms of code scanning where you actually need to fully compile the code. So why would we choose to use a tool like this? Well, it can scan all the different aspects of your code is one that's really important. Meaning that maybe during development you created functions that weren't previously called or aren't actually used in the application. We can scan those and make sure that they're not causing any issues. They also do not need to be run on fully compiled code or completed code, meaning that you can scan along the development process from day one. Something else that we've found useful at ASMGI is creating coding standards that we enforce across our development team. And that means that we are able to put rules in place to check for certain coding practices and to make sure that they are either present or not present within the scans. And a really big part of SAST is that you're able to identify issues early in the development lifecycle. As I've stated a few times, you don't need fully compiled or completed software, so you're able to catch vulnerabilities early on in the process. Once you catch one of these, you're able to remediate it earlier on, and hopefully you're able to save yourself time, effort, and money in the long run by catching these vulnerabilities early before they're actually could be a function that you're using and could have been woven into the application very deeply. It's something that you can catch before that actually happens. So now we're going to jump into the how part of how we actually conduct a static application security test. And for your development purposes, it really doesn't matter. There are a lot of great Git repositories out there, whether you're using GitHub, whether you're using Bitbucket, GitLab, or anything hosted internally. You can use any of these to actually take the repository, your coding language, and import it into either an on-premise server or a cloud instance of this type of software where the analysis is actually done. One way that we've done this is through continuous development and integration. We use pipelines, and you can set up YAML files to actually import all of your code periodically, however you have it set up, so it's constantly being pulled in, whether that's on commit or on command. So now we're going to jump into some output. Now we've taken our code and it's may or may not be completed, may or may not be able to be compiled, and we've imported it into our tool from our Git repository. And in this instance, we see that we have 2 vulnerabilities show up and 5 security hotspots. And looking at the chart then below, we're actually able to see what these are and where they are in the application. We're able to see what level they are of severity. We're able to see how long ago they were introduced into our program. If we want to drill down a little further, we need to understand what some of these vulnerabilities and hotspots actually mean. So looking at first, the most severe case would be a blocker. And a blocker would be something that would actually cause the application to crash or not work. This is a coding error, not necessarily a vulnerability. This is something that will not let the application function as it was designed. Below that, we have critical errors or vulnerabilities, and these are issues that are known vulnerabilities that can be exploited and have to be remediated immediately. These are the highest level of vulnerability under a blocker, which blocker, as we just stated, is the application won't actually run. We have major and minor under critical, which are different flaws that can actually happen within the software. They can be duplicate blocks or code smells, if you're familiar with that. Minor, then you go into flaws, which can be slightly impacting, but they can produce vulnerabilities. The other area I'd really like to draw your attention to are hotspots. And a hotspot is something that got caught in a quality gate or a flag or a rule and needs to be looked at and assessed. And why it's a hotspot and not necessarily a vulnerability is there might be a reason why the code exists and functions the way it does. And in this case, we are able to mark it as a critical, minor, major, or we might actually allow it to go out to production. It might be something that we are fine with being in the software. And in that case, it kind of is a false positive, but it flagged under hotspots. So that's why it was there for review. So now we need to take some action. We found ourselves with a few vulnerabilities. And on these lines here, we're able to drill down and really get to the root of the issue. So what is the issue? And in this case, we can see that there is a non-refer in the link in the rel tag right at the beginning there. You're able to see where the issue can be found in the application, why it creates a security issue, and when the issue was first detected, as we talked about. So this one is a moderately older one that we're looking at right here in this instance, shows 2 years of being in the system. And then we also, a lot of the applications will give you an estimate or an idea of how long it would take to remediate that sort of defect. Let's drill in a little more here. So a lot of these programs will allow you to actually drill down right into the actual bit of code. And in here, we can see that it actually pulled up the exact file and line and underlined what the issue was. So they're saying that we need a stronger encryption method here for this algorithm. Digging in a little more, and in this tool that we used, it allowed us to actually pinpoint this exact one. And if you can see, we have non-compliant code examples, and ours is actually in there where it shows that it creates a vulnerability. It also offers up a compliant solution. So it gives you the opportunity to be able to go ahead and remediate quite quickly when you know what you need to change. So moving forward, and what are keys for success when using a SAST program? I would say one of the largest issues is language support. You will find looking at a lot of these different tools, they do certain languages well and others might be a little forgotten or take a little longer to set up. So when choosing a software application to do your SAST reports and testing, you really want to make sure that it offers the languages that you are going to be working in. Another issue is the time it takes to run a scan. So to actually run over all the code base, it can take quite a while for it to actually process. One way to mitigate or work around this is to have your scans scheduled and to run daily would be one choice you could do. Another way is to actually have it work also on code check-in. So when you actually submit your code to your repository, it can trigger a pipe to conduct and actually do the scan. So if you have it set to automatically run at a period of your choosing, as well as on code check-in, we feel you're pretty adequately covered in that case. And as we saw with the hotspots, the results can include a lot of false positives. This is something that we've run into. It can be an issue, but it's better to catch them, flag them, and review them. If you find that you continually get the same false positive for a certain bit of code that you reuse or a certain type of way you code, you can fine tune your rules to actually allow you to exclude those from future reports and alleviate them showing up as a false positive in your reports. Now we're going to move on to software composition analysis, or SCA for short. This is a much newer tool to the market. It's something that we've incorporated and found great use across the board with our applications immediately. But what it is it generates a report or listing of all the components, third party and open source, that you've included in your application. It'll show licenses that are out of date, depreciated dependencies, vulnerabilities, and potential exploits. So looking back, and let's actually go on to the next slide here. Why SCA was created was it was created out of an ongoing usage of these open source and third-party programs. So what you'll find is a lot of the applications, as we've progressed through history, are using more pre-built packages that they include. And to keep a list of all these parts and pieces that you have in your application and to make sure that you're on the latest, greatest version or not on one that has vulnerabilities is quite time consuming and really quite a headache. So that's what SCA was really born out of, the need to keep your third-party components compliant, vulnerability free, and licensed and current. So how do we conduct a scan? Well, it's a little bit similar to how we did the static code analysis. We have our Git repository again with our code base, and we actually go ahead and import it into whether it's an on-premise or a cloud-based solution for the application. And what type of output can we expect here? Well, right here we get similar to what we've seen in the static code scans. We get high, mediums, and lows for severities. And what we can figure out from looking just top down when we click into a report is what version of open source the code, excuse me, what version of the open source component introduced the security issue, why it's a security issue, and what type of exploit or attack is done, and what version you need to upgrade to make sure that you are back in compliance. So if we take a look at this report that was run, we see we had 35 high, 26 medium, and 0 low. And one of the instances of the high here was for a plugin that we blanked out for purposes of this demonstration, but you'll see that it is causing a cross-site scripting vulnerability. And you can see it was introduced relatively recently on October 14th of 2020. You can see the maturity. Proof of concept means that the vulnerability was actually able to be executed, and they actually were able to put it into play. So it is an issue. You can see what files were analyzed as well as where we pulled it from. So in this case, our repository was Bitbucket. So let's drill in a little more. So we've got our vulnerability module, which is actually blocked out here, but we see that we have a cross-site scripting possibility for a vulnerability. Again, proof of concept, and it was introduced through version 7.2.1. So we can see that it's fixed. If you go down a couple more lines, it's fixed in 7.2.2 all the way through 8.1.1. So introducing in 7.2.1 is where it came about, and they give a little update as well as what the affected version of this package could do. So again, that was the cross-site scripting. Really, a lot of these tools will give you as much information as you need as you keep digging in to really fully understand why it's a vulnerability and again, how to resolve it. So some keys for success with SCA tools. You might have a potential issue with the impact of your workflows and routines. With any of these tools, not enough just to set it and forget it. You actually have to make it part of your work habits. So that would be running scans on check-in, as we've talked about, or scheduling the reports to run automatically. How does this impact your team and what they're able to produce? Well, they need to build into their work schedule a process to review these reports. And once you've reviewed them, actually come up with remediation for issues and staying on top of them. And as we saw in our past example, it was a relatively recent exploit that came out. It showed up on the 14th. That's something that needs remediation quite quickly. And then one other thing I'd like to speak about, and this applies to most tools, you know, the static as well as the SCA, is the on-prem version if it goes out of date. Meaning that if you host your own version of one of these tools, you must make sure it is locked down. You must make sure it stays up to date. Currently, we've been using cloud tools for a lot of ours. And by doing that, we are able to have the most up-to-date current lockdown version without having to worry about that in-house. But there are cases where it might make sense for you to do that in-house, and that would be having a little more customization over what the software is actually doing, possibly having some records stored on your servers and not on third-party servers. And now I'm going to hand over the conversation to my colleague Tim, where he's going to talk about dynamic application security tests.
Thank you, Alex. In dynamic application security testing, the main thing with here is once you get the code pretty much scanned and you're ready to go, get into development or into the actual production of the application, you can run the dynamic application security testing to just test your code as it is live. And what dynamic application security testing is, it's a black box security testing methodology in which an application is tested from the outside. So you're looking at it from, just like an attacker, you're looking at it from the outside into the application. Different types of DAST that you can use is what I'd say authenticated or unauthenticated. Authenticated is really getting a user access. If you're going to log into the application, you're logging in as a user. What's good for testing is you have a user that has either admin rights or configuration rights, and that'll give you a better quality of testing. And then, like I said, it'll allow you to drill down into the application and crawl as the application is being scanned. It'll crawl down into different aspects of the web pages that the user has access to. And what it is good to find external vulnerability issues and visible issues with the application. It identifies runtime problems, and definitely if there's any server configuration or authentication issues, it will be able to find that. Some of the things we've seen in the past is where just a regular user gets access to a menu or screen that maybe an admin or configuration user may have. And like I said, this is an application runs like a hacker would be trying to attack your application. And pretty much the steps in doing a DAST test is pretty much you want to know your URL IP address of the applications. Most tools will have you input that URL or that application. Some tools allow for HTTPS and HTTP selection, or just generally the overall URL is put in, or IP address. And then you also are given different profiles you can use. And most times they'll have the option of a security profile, either OWASP top 10 or SANS top 20. And then some even offer you to have the ability to put in a custom profile, whether you have either PCI, HIPAA, or some other compliance requirement that you may want to check for, or if it's a particular vulnerability that you may want to check for. And then what it'll ask for is whether you want to authenticate it, and then it'll ask you for the username and login that you'll use for that. And then you'll initiate the scan process. Pretty simple steps in most of the tools that I've seen and used. Now, if you've chosen the OWASP top 10, what you may get in some of the tools that we use it lays it out this way. It gives you, for each category, how many vulnerabilities it found, the percentage of the vulnerabilities that have that. And also another area, some may have both of these, some may just have one or the other, is the severity level based on the criteria within the tool to determine what severity you set or the system sets for vulnerabilities that it may find. I know a lot of us, what the common ones we see are usually level 3 concerning like a whole library or things like that. That's a very, very common one. So once it gives you the vulnerabilities, most of the tools, and I know the one that we use, will provide a drill down. So to give you the vulnerability, it'll tell you, okay, this is the threat for the vulnerability. This is the impact it could have on your application. Here's how you can resolve that vulnerability. And then it'll give you where in the code that it found that particular vulnerability, which web page, which screen, or which form. And once you've understood what the vulnerability is, where it's at, you can remediate it. And then we always suggest an iterative approach to remediation. And that means pretty much in a couple of rounds of scans just to make sure you get all the vulnerabilities. I mean, some things you may not can change and you just say, oh, I'll live with that. But you want to go through a couple of times to make sure you get all the vulnerabilities out of the way and what's acceptable to your organization. Moving forward, keys for success. One of the downsides of the DAST scanning is that it doesn't have code visibility, and that's why we use it in complement with the SAST and SCA tools that Alex spoke about earlier. And we find that between the 3 tools, it gives us a good grasp of the application, any vulnerabilities that we may find and we have to remediate. One of the potential issues with scans, as like you all know, can take a long time depending on the application, how many pages or menus you have to go through in the application. So one way around that is scheduling and scheduling the scan at different points within the workflow of your SDLC process. And I would suggest earlier in the process that you can do scans, the better. And I know we usually go through when first we get the code up, we'll take a scan before we put it in production. Then we'll take a scan after production as well. So it's up to you to decide where you want to fit those scans in, but the earlier in the process that you can scan, the better. And always having a good security profile, depending on your business requirements, is good to know. I mean, you'd hate to scan and then realize you have a vulnerability that you really didn't look for, but your company has a requirement based on the compliance with PCI, HIPAA, or some other form of compliance. So you always want to make sure you check your profile. And most of them, they'll have the OWASP or SANS top 20 as a base, and you can add or retract from that as needed. And always, 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 if you can have a authenticated scan, please use that. I mean, at admin level or configuration user level would be what my recommendations are, but at least at admin level so that you can get to all the menus and web screens that the application may have.
Yeah, I'd just like to chime in and say that is something we've noticed running these scans where, like Tim had mentioned, we do see other menus that users aren't supposed to get access to or other functions, and they're able to access them. And this dynamic application scanning really allows us to see those types of things and remediate them.
And just some examples of tools or solution providers that we're familiar with when it comes to the static application scanning. You have SonarQube, Sonar Cloud, Veracode, Coverity. Some of the SCAs is White Source, SNCC, Veracode, Black Duck, Fossa, and some of the DAST tools are Qualys, Rapid7, Veracode, Tenable, NetSpark are none of the same tools you use for your other vulnerability scanning.
And I'd say this choosing your tool is something you really need to take a long time with, making sure that you get the right fit for your company. We took our time with a lot of different offerings and set up POCs where we were actually able to test it out on some of our software, make sure the reporting fit our needs, make sure the price point fit our needs, make sure that they had all the functionality and tie-ins to the right repositories and languages as I spoke about. But really taking your time in identifying what solution is right for you will save yourself a lot of headaches down the road.
Yeah, and what we found too is if you have like a third-party development company working on your code for your applications, this is always a good sanity check to make sure that they're making good, secure code.
Definitely. The SCA tool, for one, will show you all the components that were used. So if you're inheriting an older code base and you're not sure what all is in it, it's something that'll bring those items to light where you're actually able to go ahead and make sure they're current and make sure they're fitting your needs.
Yeah, and I'd just like to thank you guys for tuning in to our session on the DevSecOps tool workshop, and look forward to talking with you again.